Hi, these are the notes that you can put on page 20B about fractions to decimals and classifying real numbers. So starting here, if you are converting fractions to decimals, you have your fraction. The fraction bar means to divide, and you have to do them in that order. So it'll be 7 divide by 8. Feel free to use a calculator, but to kick it old school, I went ahead and wrote the long division on here for you. So the 7, the first number goes on the inside, so 7 divide by 8. Well, nothing goes in, or you can't put 8 into 7, so you skip it. And then now your number becomes 70. Don't forget to move your decimal point up there. 8 times 8 is 64. You subtract, you get 6. Until you get to where it's a 0, you should keep going to continue the decimal. So you bring down another 0. 60 divided by 8 would be 7. 7 times 8 is 56. Subtracting, you get 4. Bring down another 0. 40 divided by 8 is 5. 5 times 8 is 40. You finally got your 0. And so 7/8 equals 0.875. Moving over to going in the opposite direction, if I give you the decimal 0.012, what you do is if you read it correctly, it would say 12 and then your place value, 10th, 100th, 1000th. So to read this correctly, it'd be 12 thousandths. And so you'd have your 12 on top and then 1,000 on bottom. The other way you can look at that is you can count how many numbers after the decimal point there are. So since there are 3, 1, 2, 3, it's a 1 with 1, 2, 3 zeros. So it'd be 12 over 1,000. And then you can simplify. You can divide both of those by 2, so 6 over 500. You can still divide both of those by 2. So then you get 3 over 250. So 12 thousandths, 0.012, equals 3 over 250 as a fraction. If you have 1 and 45th hundredths, your 1 is your whole number, right? So it's the one that's going to be on the left of the decimal. It's the whole number of the fraction. So you can bring it down and then just focus on the 45. Again, it's 45 hundredths, or think of it as there are 2 numbers after the decimal. So it's a 1 with 2 zeros, 100. So 45 over 100, you can divide both of those by 5 and get 9 over 20. 7.6, or 7 6/10. 7 is your whole number, so bring it down. You only have to focus on the 6. 6/10, or there's only one number after the 0, so or one number after the decimal, so you only need 1 0. 6/10, you can divide both of those by 2, becomes 3/5, and you get 7 3/5. Repeating decimals to fractions. I can show you a complicated algebraic way to do this when I get back to school, and maybe the video that you could watch instead of listening to my video would have that complicated way if you're interested. But basically what I do is I see how many numbers are repeating, how many digits are repeating after the decimal. In this case, the 3 is repeating. So the 3 is repeating, and I'm going to put it over 9 because there's only one number repeating. So just like up here, we were putting it over 10 or 100, depending on how many numbers. Here, we're going to put it over that many 9s. One number repeating, put it over 9. 3/9 equals 1/3. One more time. How many of those numbers are repeating? 1. So it's a 6, and then since 1's repeating, you put it over 9. So 6/9. You can divide them both by 3 and get 2/3. This one, same thing. One number is repeating, so you can make it 8/9. Down here, you'll see that there are 2 numbers repeating. The 1, 8. And so since there's 2 digits repeating, you write those at the top, and then you'll write 2 9s, so it'll be 18 over 99. Then when you simplify, you can divide them both by 9, and you get 2 11ths. And then here, if we had the number 0.1666, 1666, 1666. There are 4 digits repeating, and I know it cuts off down here, so I'm really sorry, but this is a 9999. So you have 1666, because 4 digits are repeating, over 4/9. And I don't think that one simplifies. Again, like I said, you can watch the video on my content page to hear someone else explain how to do those. Classifying real numbers. So real numbers are all the numbers that you're going to deal with until you get to Algebra 2. And then there's some imaginary numbers, but we won't talk about those right now. You have irrational and rational numbers. Irrational numbers cannot be written as a fraction. So these are going to be the ones that have square root that are not perfect squares. It's going to be like pi, which doesn't have an ending point. It doesn't repeat, but it doesn't terminate. So it's 3.14159265358979323 da 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 da. That would be an irrational number. Rational numbers are all things that can be written as a fraction. So up here, we just learned that terminating decimals that stop, can be written as a fraction. Down here, if the decimal repeats, it can be written as a fraction. So anything that can be written as a fraction is a rational number. Inside the rational numbers, you have all of your integers. Your integers are the whole numbers and their opposites. So like -3, -2, -1, 0, 1, 2, 3. You won't have any decimals, won't have any fractions when they're all simplified, but you could have positive or negative numbers. Whole numbers are positive, just the positive integers. So 0, 1, 2, 3, 4, 5, 6, 7. And then inside that, you have your natural numbers. These are the ones where you naturally start counting. So when I tell you to start counting, you start at 1. So it's 1, 2, 3, 4, 5. So 0 is not a natural number. So down here are some examples. You'll see that 0, it is a real number. It is rational. It is an integer. It is a whole number, but it's not a natural number. The square root of 49, we can simplify that to be 7. So since we know that this one is 7, because 7 times 7 is 49, we can call it real, we can call it rational. It's an integer because there's no decimal. It's a whole number because it's positive, and it's natural because when you naturally start counting, you would count 7. 45 over 7, it looks like a fraction right now, right? So therefore, it's a real number. And it's a rational number because it can be written as a fraction. The fraction is 45 over 7. But it doesn't divide out evenly. And so since there would be a decimal when you made this a decimal, there would be a decimal there when you divided it out. So therefore, it's not integer, so you'll stop at rational. 3 is a positive whole number that you naturally count. So it's real, it's rational, it's an integer, it's whole, and it's 0. Down here is pi. Pi is going to be a real number, but like I said, it never has a stopping point. It doesn't terminate, but there's also never a place where it starts repeating the decimals over and over again. So therefore, it's an irrational number. You cannot write pi as a fraction. You can get close, there's an estimate, but you can't write it as a fraction. And I cannot tell what's underneath that, so you'll be on your own to find that one if there is something there. The square root of 3, we do not know what the square root of 3 is. We know the square root of 4 is 2, but the square root of 3 is going to be a decimal. And so if it's going to be a decimal, all square root numbers that aren't perfect squares are never going to repeat, but they're also not going to terminate. They're not going to end. So square root of 3 would be a real number and irrational. -12, well, it can be written as a fraction. So, everything's a real number that you're going to deal with. So you know it's a real number. It can be written as a fraction because you could put it over 1. And so it is rational. It does not have a decimal with it, so you know it's an integer. But since it's a negative integer, it will not be considered whole or natural. So -12 is real, rational, and integer. I hope these notes help you on page 20B.